some review questions for what we have been discussing. The first one is express 6.20 milligram in kilograms. Here we are asked to convert milligram. We want to change milligram into kilogram. How do you convert it? As I told you before, you have to know the term prefixes. Prefixes are words or symbols which are added before another word. Milli is a prefix which belongs to or refers to 10 to the power of -3, whereas kilo is a prefix which refers to 10 to the power of +3. This is what you have to know first. So I want to change this milligram to, our objective is we want to convert milligram into kilogram. So let's see how to. So 6.20 milligram is the same as, I can write this as 6.2. Milli is a prefix, and instead of milli I can need this multiplied by 10 to the power of -3 gram. I'm just substituting 10 to the power of -3 in the place of this milli. For this place I'm using 10 to the power of -3. Now the next step is I have to write 10 to the power of -3 as a product of two numbers. I can write, because I know kilo is 10 to the power of 3, I want to write 10 to the power of -3 as a product of two powers of 10. I can write this as 10 to the power of 6 -6 multiplied by 10 to the power of 3. I can write it because these two have the same base. I can take 10, then add the exponents. -6 plus +3 will be -3. So I can use this. So this is equivalent to 6.20 multiplied by 10 to the power of -6 multiplied by 10 to the power of 3 gram. And this is the same as 6.20 multiplied by 10 to the power of -6. I know that 10 to the power of 3 can be substituted by the prefix kilo. So this is equivalent with kilo prefix and have gram. So this should be the answer. So 6.20 milligram is the same as 6.20 times 10 to the power of -6 kilogram. So this is what we have to know is, we have to know the word prefixes milli and kilo, because the prefixes that we have in this problem are milli and kilo. Now let's move to the second example. How many significant figures does this number has? We want to know the number of meaningful numbers that we have in this length. By the way, 25.0 is a unit of length. As you can see, its a unit is meter, so it belongs to the physical quantity length or distance. They are the same. This is a physical quantity that belongs to meter, or length, which is the same as 25.08 meter. How many significant digits that this number has, or figures, significant figures or digits? Now just to make this clear, let me show you a table. There are rules that helps us determine whether a given zero is significant or non-significant. But before that, what is the meaning of significant figure? What's a significant figure? Significant figures are digits in a measurement that are known with certainty plus the first digit that is uncertain. Or significant figures are figures in a measurement which are meaningful. Or significant figures help us keep track of imprecision. Now let's see the rules for determine whether the zero are significant figure or not. The first rule is zeros between other non-zero digits are significant. Like here 50.3. This zero is sandwiched between two numbers. In this case, this zero is significant. In this particular example, we have three significant figures or digits. 1, 2, 3. This has three significant figures or digits. Let's take the second example. This second 3.0025 seconds. Now these zeros are sandwiched, or they are found between two numbers. They are found between two numbers. So in this case, they are counted. They are significant. So we have 1, 2, 3, 4, 5. We have 5 significant figures or significant digits. The second one is zeros in front of non-zero digits are not significant. For example, here, let's see, 0.892. It could, like, call it a kilogram or whatever you want. In this case, this zero is in front of non-zero number. Like, it's in front of one non-zero number. In this case, this zero is not significant. We don't count it. So in this case, how many significant do we have? 1, 2, 3. We have 3 significant figures. Let me give another example. If you have 0.0008, in this case, we don't have any number in front of these zeros. So in this case, all these zeros are not significant. These are not significant. We have only one significant figure. In this case, we have only one significant figure or one significant digit. The third rule is any zero that are found at the end of a number or to the right of a decimal are significant. For example, in this case, look, this is a decimal point, and after this decimal point we have 2 zeros. In this case, these 2 zeros are significant. These are significant. Now in this particular example, we have 4 significant digits. 1, 2, 3, 4. In this case, we have 4 significant figures. Let's say the second case. Let's see the second case. After decimal, this decimal, we have 6 zeros. We can count them. 1, 2, 3, 4, 5, 6. Now these 6 zeros are significant. We count them. So we have 6 zeros and 1, 2. All together we have 7 significant figures or significant digits. The last rule is numbers which are written in this form, we cannot say that they have 1 or 2 or 3. They can have 1 or 2 or 3. We cannot exactly tell the number of significant figures they have, because let me show you. For example, 1000 can be written as, I can write this as 1.000 multiplied by 10 to the power of 3. In this case, this has how many significant digits? 1, 2, 3, 4. It has 4 significant figures. I can also write this as 1.00 multiplied by 10 to the power of 3. I can. So in this case we have how many significant figures? In this case we have only 3 significant figures. So numbers which are written in this way do not have fixed number of significant figures. They change. The number of significant figures varies or changes because we can write them as a power of 10 in a different ways. That's why we cannot exactly tell the number of significant figures they have. So numbers written in this way have no fixed number of significant figures. Now let's come back to our question. Let's get back to our question. This case, as I explained earlier, 25.08 meter. This case, this 0 is sandwiched, or it's found between two. We found it before between two numbers. So according to our rule, this 0 is significant. We count it. It is significant. We count it. So this number has 1, 2, 3, 4. It has 4 significant digits. This number has 4 significant figures. Then the answer will be B. Let's move on to the next example, third example. What are the areas or branches of physics? Area, when you say area, we mean branch of physics. We know that there are different branches or areas of physics. So what area of physics deals with the behavior of subatomic particles? We know that an atom is made from the central part, nucleus, and the one that revolves around its orbit, that is electron. And inside the nucleus we have protons and neutrons. So a branch of physics that studies about the subatomic particle of an atom or subatomic particles of any element is quantum mechanics. The answer is quantum mechanics. We know that mechanics is a branch of physics that studies about the motion and its cause. Thermodynamics is a branch of physics that studies about heat and temperature. Electrodynamics it's a branch of physics that studies about the moving particles or moving charged particles. Particles or charged particles which are moving charged particles. When you put a charged particle in a uniform electric field or magnetic field, it will move. So a branch of physics that studies about the motion of this charged particle is called electrodynamics. And the fourth one is quantum mechanics. This studies about the behavior of the subatomic particles. How do they look like? So these are the different areas or branches of physics. Fourth example is each physical quantity has its own SI unit. There are physical quantities these physical quantities do have their own SI unit. For example, mass is a physical quantity and its SI unit is kilogram. Time is a physical quantity, its SI unit is second. Length is a physical quantity and its SI unit is meter. The speed is a physical quantity and its SI unit is meter per second. Force is a physical quantity, its SI unit is Newton. So each physical quantity has its own corresponding SI unit. For example, mass is a physical quantity, its SI unit is kilogram. Time is a physical quantity, its SI unit is second. Length is a physical quantity, its SI unit is meter. Speed is a physical quantity, its SI unit is meter per second. Force is a physical quantity, its corresponding SI unit is Newton. So what is the SI? The question says, what is the SI base unit for length? This length. So the answer will be meter. But when we say meter, we don't mean that kilometer, foot, inch are not the units of length. They are units of length, but it says SI unit, International System of Unit, or System of International D units. So the SI unit for length is meter, but it has other units, or non-SI units, or they are what? Non-SI units. These non-SI units are kilometer, centimeter, millimeter, inch, miles, feet, etc. So each physical quantity has its own corresponding SI unit. That's all what we have.